So for our 4760 project, we created a sign language glove.
And we is?
Monica Lynn and Roberto Hilda. We basically took a glove, and for the purposes of this project, our goal is to translate sign language into spoken English. However, with the algorithm that we're using, a machine learning algorithm, it can be generalized to basic gesture recognition. Anything you input can eventually be predicted.
All right, and I see flex sensors on the fingers.
Yes. So we have 5 flex sensors, one for each finger, to basically detect how much the finger bends. On the back of the glove, we also have a 3-axis accelerometer and gyroscope to detect the orientation and rotational movement of the hand. We later also added some copper tape for contact sensors to detect the difference between more similar signs. For example, U and V are very similar in terms of the orientation of the hand and how much the fingers are flexed, but visually they're very different, so we needed some way to differentiate between the two.
I see. So the copper sensors. There's another sensor on the other side of that finger.
Yes,
okay.
There's also R, which is like this. So we had to figure out. So there's R, U, and V.
So essentially, those sensors are mostly there for differentiating those 3 letters.
For R, U, and V.
The rest of them can be captured fairly well by the accelerometer, the gyro, and the flex sensors themselves.
Okay. And then the microcontroller over here is interpreting all of the sensor data and then talking to the laptop, which is doing what?
So currently the microprocessor is gathering all the sensor data and performing some filtering on it. And then it's sending those packets to the laptop, which gathers all the data, and either, if you're training it, starts gathering into a data set. And if you're predicting, then it gets a previously existing data set. It performs machine learning on it. We're currently using support vector machines. And then as new data is coming in, it generates predictions for it and outputs it to the user through visual format and through audio.
All right, so demo now. Let me see, put the glove up near the screen so I can see both of them at once. All right, so make a gesture here.
So if you want to get like the A, B, C, D. And if you just go, one of the, so we trained it on the full alphabet, but we also added in 2 more classes, one being relaxed and the other one nothing, so that it didn't output anything when we weren't predicting something.
Gotcha.
So, for example, if you want to write something like E, S, D, A, I, S, double, O, R, K, S. And so,
wow, that's quite good. Looks like you've been practicing too.
Yeah, so some of us learned sign language through the process of this.
Well, so it worked for learning.
Yeah, actually.
And when you were training this, how did you do that? How long did it take? How hard was it?
It took a while. We eventually got it up to taking about 500 samples per letter and per movement, I think. So overall, that took quite a while. And another thing was, it was important to make sure we took the samples in like different orders, just to make sure that like the transitions between them weren't really like consistent. 500
reps for each letter. So this was a significant amount of time to do the training.
So it took about, I want to say, 30 minutes or so. So essentially the microprocessor's streaming data at 33 hertz. And what we did was that there's a script that goes to the full alphabet and the nothing and the relaxed. But we did it at 100 samples per thing, per iteration, and we put it in randomized order so that the user wouldn't predict and would capture them at different parts. So for example, initially we captured all 2,000 samples per thing, per label, but continuously. And what happens is that once you put your hand in a certain position, you just leave it there. But later on when you go to do it, you might put it slightly differently. And we noticed that was actually an issue, so we said, okay, let's have the user make the sign several times for the data set. So actually a big part of it is just going, okay, I got that letter, go to the next one, go to the next one, so on and so forth. Also, the size of the data set is going to depend. Right now we have it trained on Monica and myself, and we've tried it with different people with the same training, and it's worked fairly well. But as more and more users come, it's very likely that when a new user comes, you only have to train on very specific letters. Like, for example, the difference between S and M is kind of difficult for the flex sensors to detect. So a new user may just be able to train, well, this is what my S looks like, this is what my M looks like, and the rest can be generalized from the bigger data set.
But even 30 minutes is not a bad training time for a new user. That's certainly doable. I was visualizing a day or something, but 30 minutes is completely doable. Well, that's very cool. Demo it one more time, please.
A I B U U O E D O W O U L I K E D A I S.
We don't have a question mark.
Okay, thank you.